At this very moment, there are jets in the sky that most radars on Earth cannot see. Pilots flying machines so advanced that the fight is decided before the enemy even knows a battle has begun. These aren't just fast planes with missiles, they're flying supercomputers built to dominate the sky in silence. And that's exactly why some of the world's most powerful countries are nervous, watching closely, and quietly preparing ways to challenge them. How did U.S. military jet planes become so far ahead of the rest of the world? And why has that advantage turned America into a target in the global race for air superiority? At this very moment, high above the clouds, there are jets moving faster than sound that most radar systems on Earth cannot even see. No warning alarms, no blinking screens, just silence until it's too late. These are not ordinary aircraft. They are flying supercomputers, built to decide wars before the first shot is fired. And this overwhelming advantage is exactly why the world pays close attention to U.S. military jet planes, why rival nations study them, fear them, and in some cases, actively try to counter or target them. The question isn't just how fast these jets are, it's how the United States became so dominant in the skies, and why that dominance has turned into a global challenge. To understand this, we need to go beyond speed and missiles. U.S. jet superiority begins with technology that is often decades ahead of its competitors. Modern American fighters like the F-22 Raptor and the F-35 Lightning II are designed around one core idea: see first, strike first, and never be seen. Their stealth shapes are engineered to scatter radar waves, making them appear as birds or background noise on enemy screens. Even when detected, it's often too late to track them accurately. But stealth alone is only part of the story. These jets are packed with sensors that collect information from every direction: radar, infrared, satellites, and even other aircraft, then fuse that data into a single, clear picture for the pilot. While older jets force pilots to interpret raw information, U.S. jets deliver instant battlefield awareness. But even the most advanced jet is useless without the human inside it. This is where U.S. pilot training becomes a decisive advantage. American pilots fly more training hours than most of their global counterparts, often in highly realistic combat simulations. They train against aggressor squadrons that mimic enemy tactics, aircraft, and even communication styles. Mistakes are analyzed in detail, and lessons are immediately fed back into training programs. The result is pilots who are prepared not just for one-on-one combat, but for chaotic, multi-threat battles involving missiles, electronic warfare, and surprise attacks. In many conflicts, U.S. pilots have won engagements without ever being seen by the enemy, a testament to both technology and training working together. What truly separates American jets is how they fight as a team. A single U.S. fighter is dangerous, but a network of them is overwhelming. Jets communicate with each other, with drones, with ground forces, and with satellites in real time. One aircraft might detect a threat, another might launch the weapon, and a third might never reveal its position at all. This kind of networked warfare means battles are no longer about dogfighting skills alone, they are about information dominance. Whoever controls the flow of data controls the sky. Even without direct conflict, the presence of U.S. jets near a region sends a powerful message: escalation will be costly. What truly separates American jets is how they fight as a team. A single U.S. fighter is dangerous, but a network of them is overwhelming. Jets communicate with each other, with drones, with ground forces, and with satellites in real time. One aircraft might detect a threat, another might launch the weapon, and a third might never reveal its position at all. This kind of networked warfare means battles are no longer about dogfighting skills alone, they are about information dominance. Whoever controls the flow of data controls the sky. As the future unfolds, the sky is becoming more crowded and more contested. Drones, artificial intelligence, hypersonic weapons, and space-based systems are changing the rules of air combat. Yet the core principle remains the same. Dominance comes from integration. The United States doesn't rely on one jet or one technology, it relies on a system where aircraft, pilots, data, and strategy move as one. Another critical factor is money and industrial power. The United States spends more on defense than the next several countries combined, and a significant portion of that goes into air superiority. This budget fuels constant research, testing, and upgrades. Unlike many nations that buy jets and fly them unchanged for decades, the U.S. continuously updates its aircraft with new software, sensors, and weapons. A jet delivered today is not the same jet flying 5 years from now. It's smarter, more connected, and more lethal. Behind this system stands a massive defense industry, thousands of engineers, and an ecosystem that allows rapid innovation at a scale few countries can match. This is why some countries don't just compete, they actively try to neutralize U.S. air power. Targeting doesn't always mean shooting jets down. It often takes subtler forms. Cyber operations aim to disrupt communication networks. Engineers work on anti-stealth radar designed to detect what was once invisible. Long-range missile systems are built to keep U.S. aircraft farther away. Propaganda campaigns attempt to question the effectiveness or cost of American jets, hoping to weaken political support. In other words, when you can't match air dominance directly, you try to undermine it from every angle. At the same time, global rivals are racing to build their own advanced fighters. New jets are announced with bold claims of stealth and speed, but building an aircraft is only part of the challenge. What's harder and far more expensive is creating the training, logistics, maintenance, and combat experience that make those jets truly effective. This is where the U.S. maintains a long-term advantage. Decades of real-world operations, from deterrence missions to full-scale wars, have shaped how American air power is used, refined, and improved.